Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Well, dear students, let's move to the next set of questions. So, question number 10 onwards. If secant x minus y divided by x plus y is equal to a, where a is a constant, then find dy by dx. The options are very simple. Alright, that means the solution would be a very simple thing. Now, what you need to do is you can differentiate this secant, but if you use inverse trigonometry here, your solution will be very simple. So, what I will do is x minus y divided by x plus y is equal to, so that becomes secant inverse. So, this is secant inverse of a, right, and which is a constant. When differentiation, this part becomes 0. So, when you do the differentiation with respect to x, you have to use quotient rule here. Fine, we will do that, but here you will get 0 because a is a constant, hence secant inverse of a is also a constant, derivative of a constant is 0. Well, use the quotient rule here. So, denominator into derivative of the numerator. So, what is the derivative of x? 1, and derivative of y dy by dx minus numerator into derivative of the denominator. Derivative of x is 1, derivative of y is dy by dx divided by x plus y the whole square. That is equal to 0, right. Now, take this denominator to the right hand side, and hence that also becomes 0. Well, now you can multiply, and you have to, because we have to separate dy by dx, we need dy by dx ultimately. So, let me multiply this. So, that would be x plus y, and this is minus x plus y into dy by dx, right, and here x minus y and minus x minus y into dy by dx, which will be equal to 0. The denominator becomes 0 there. Well, now take dy by dx common, and you can retain dy by dx on the left hand side, or you can take both to the right hand side, which will be positive on the other side. So, let me retain this here, and minus x and plus y, that is equal to, this part will be positive. So, x plus y, and then this part also will be positive, x minus y. Alright, so you do not need brackets because you have got plus, and I am taking dy by dx common. I am just skipping one step here. I hope you understand. First you take to the other side separately, and then you take dy by dx common. Well, here cancel out y, alright, and then here you cancel out x. So, that would be 2y is equal to 2x into dy by dx. So, finally, what is dy by dx? 2y divided by 2x, which will be y by x, because 2 also cancels on both sides. So, y by x is option D, and hence option D is the answer for question number 10. I hope you understood this. A simple question, alright, but the first step is very important. Take this secant to the right hand side, becomes secant inverse A. Now, let us move on to the question number 11, once again based on inverse trigonometry. Alright, so look at question number 11. Y is equal to tan inverse of. So what I'll do is I'll convert this expression in terms of tan, so that tan inverse and tan will reduce into a simple form. Tan inverse of tan theta is theta itself. So now divide by cos, because I need 1 here. In tan x minus y or tan x plus y formulas, you have got 1 here. So that's the hint for you. You have to divide by cos x. Divide numerator as well as denominator. So when you divide by cos x, this would turn out to be tan x, because it is sin x by cos x. And next you have cos x by cos x. So that will be 1 and divided by, you have got 1 minus tan x, right? So you have got 1 into tan x, or tan x means the same. So this can be changed into tan pi by 4, correct? And here also write tan pi by 4. There is a shortcut formula. If you know the formula, you use the formula. Otherwise, make this change and then you will understand what to write next. So I am writing this as tan pi by 4 plus tan x. Okay, or other way around is also fine, divided by 1 minus this 1 I am changing into tan pi by 4, tan 45, and here we have tan x. Now look at this. What is it? This is tan x plus tan y divided by 1 minus tan x tan y, which is tan x plus y. So this is tan pi by 4 plus x, correct? Tan x plus y formula. Now tan inverse of tan, okay, will be reduced into only the angle of tan, that is pi by 4 plus x, which is still y. Now we have reduced it into a simplest form. Differentiation can be done. So differentiation with respect to x will result into dy by dx. That's equal to derivative of pi by 4. What is pi by 4? Is a constant. So derivative of a constant is 0, right? And derivative of x is 1. So dy by dx is 1, which is option D, and that's the answer for question number 11. Alright, now come to the question number 12, which is also based on inverse trigonometry, and a very easy question with the complicated options. Alright, so there is only one simple option, maybe that could be the answer. Let's check. Alright, because the question is simple. Why? The formula is tan inverse x minus tan inverse y. So what is it? Inverse trigonometry formula, that is tan inverse of x minus y divided by 1 plus xy, right? Alright, and the condition follows, but not necessary here. Okay, so there is no condition given in the question, so it doesn't matter, it is applicable. Well, now what you have got here is the right hand side. Okay, in place of x we have a, in place of y there is x here, correct? And then xy is ax. So what do you need to write in this place is the ALHS. So let's begin with that. So d by dx of tan inverse of a minus x divided by 1 plus ax is nothing but derivative of, I should write this, so that is tan inverse of A minus tan inverse of x. So that's it. So you just have to differentiate this. What is the derivative of tan inverse A? 1 by 1 plus A square. Is it that the derivative? No. A is a constant. Tan inverse A is also a constant. Derivative of a constant is 0. So when you differentiate it, 0, and derivative of tan inverse x. What is the derivative of tan inverse x? 1 by 1 plus x square. Hence the answer is minus 1 by 1 plus x square and not option B. It is not 1 by 1 plus a square. It is 0 because tan inverse of A is 0. Well, so option A is the answer, the simplest one. And maybe you may think because you have tan inverse of u, derivative could be 1 by u square, 1 by 1 plus u square, right? No, this is not the option because you have to continue, you have to use chain rule. Tan inverse of u is 1 by 1 plus u square, then derivative of u has to be found, right? So derivative of this has to be found using quotient rule, and then you have to simplify, which will convert into this itself. Okay, so this is not the complete answer, this is only the first part of the answer. Chain rule is not used here, so option C cannot be the answer there. Okay, and option A is the answer for question number 12. That's it for this class. Let's continue with the next set of questions in the next class. So thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.